Hook, have you ever wondered what a newton really feels like? Imagine lifting a heavy object, feeling the strain in your muscles. That force you're exerting is measured in newtons. But what does 1,000 newtons actually feel like? Let's find out. Building context, before we dive into the specifics, let's understand what a newton is. In simple terms, a newton is the unit of force in the International System of Units, SI. It's named after Sir Isaac Newton, the renowned English physicist and mathematician. Real-world examples. To give you a better idea, let's consider some real-world examples. Lifting a weight. If you've ever lifted a barbell at the gym, you've experienced newtons. Each kilogram of weight you lift exerts a force of 9.81 newtons. So, if you're lifting a 100 kilograms barbell, you're exerting a force of approximately 981 newtons. Pushing a cart. Pushing a grocery cart filled with heavy items is another example. The force you apply to move the cart is measured in newtons. The heavier the cart, the more newtons you need to push it. Pulling a rope. Imagine pulling a rope with all your might. The force you're exerting on the rope is measured in newtons. The harder you pull, the greater the force. Visualizing 1,000 newtons. Now, let's try to visualize 1,000 newtons. It's a significant amount of force, but it's not as much as you might think. Lifting a person. To lift a person weighing around 100 kilograms, you'd need to exert a force of approximately 981 newtons. So, 1,000 newtons is roughly equivalent to lifting a person slightly heavier than that. Pushing a car. Pushing a car with moderate force can also generate around 1,000 newtons. Imagine pushing a car up a slight incline. Pulling a heavy object. Pulling a heavy object like a large crate or a piece of furniture with considerable effort can also result in a force of around 1,000 newtons. Experiments and demonstrations. To make this more tangible, let's conduct a few experiments. Spring scale demonstration. We can use a spring scale to measure the force exerted by various objects. By attaching different weights to the spring scale, we can see how the reading changes. Human power experiment. We can also measure the force exerted by a person. By having someone pull on a spring scale with varying degrees of force, we can see how the reading corresponds to the perceived effort. The importance of newtons. Understanding newtons is crucial in various fields, including engineering. Engineers use newtons to calculate forces on structures, machines, and other objects. Physics. Physicists study the laws of motion and force, which involve newtons. Sports. Athletes often train to increase the force they can generate, whether it's in hitting a baseball or lifting weights. Conclusion. So, what have we learned? 1,000 newtons is a significant amount of force, but it's not as overwhelming as it might sound. By understanding real-world examples and conducting experiments, we can gain a better appreciation for this unit of measurement. With that said, thanks for watching, and until next time.